Welcome to this deep dive. We're going to explore the vibrant world of visual tech. It's really all about how chemistry shapes the way we see and interact with the world. And you've given us some fascinating factoids about breakthroughs in chemistry, and we're going to connect the dots and uncover the why behind their importance.
Yeah, I mean, it's almost like a cocktail party where chemistry is the mixologist. You're blending all these seemingly unrelated ingredients to create something surprisingly delightful. We've got ancient remedies and accidental discoveries. We even have cutting-edge innovations, and it's all contributing to, the displays we use every single day.
Okay, so let's unpack this cocktail shaker of knowledge.
All right?
Our journey begins with mauveine. This is the first synthetic dye, and it was discovered completely by accident in 1856. I never thought a deep dive into chemistry would involve a fashion revolution.
Well, it's funny because this accident completely revolutionized the textile industry. And you have to think, before mauveine dyes were only derived from natural sources, and oftentimes these were, very expensive and limited in color options. Just imagine a world where vibrant colors were only accessible to the elite. It's crazy. But mauveine, this bright purple shade, it democratized fashion. It made these vibrant colors available to everyone.
That's fascinating. Just a single discovery could change the way people express themselves through clothing. It makes you wonder, what were people wearing before mauveine? Was it just shades of brown and beige?
Pretty much, yeah. And these natural dyes, they were often muted and faded quickly. Mauveine opened up a whole world of possibilities, leading to the synthetic dye industry we know today with, literally a rainbow of colors at our fingertips. And, thinking bigger picture, it paved the way for further innovation in chemistry. This led to the development of new materials and technologies.
Wow. From drab to fab, all thanks to a little bit of chemistry.
A little bit of chemistry goes a long way.
Now our next factoid takes us into the heart of our screens, which is, liquid crystals. I was really surprised to learn that they were discovered way back in 1888, long before flat screens were even a concept.
And what's so fascinating here is that liquid crystals are this unique state of matter. It's somewhere between a liquid and a solid. So they have the fluidity to move around, but they also have a structure that allows them to interact with light in a predictable way.
So they're like tiny organized dancers just flowing across the screen, creating the images we see.
Exactly. And it wasn't until the 1960s that scientists figured out they could use electric fields to control the orientation of these liquid crystal molecules, effectively making them, the tiny shutters that control the passage of light. And that's really the foundation of LCD technology, the screens you're probably looking at right now.
It's amazing to think something discovered in the late 19th century would become so integral to our modern digital lives. Speaking of light, let's move on to photochromic lenses. The lenses that darken when they're exposed to sunlight. I remember I was so fascinated by these as a kid. They just seemed like magic.
Well, the magic lies in clever chemistry. You see, these lenses utilize molecules that change their structure when they're exposed to UV light. And this change actually affects how they absorb light, causing the lenses to darken. When the UV light is removed, the molecules just revert back, then the lenses become clear again. So it's like a tiny, reversible chemical reaction happening right on your eyeglasses.
So it's all about manipulating light at a molecular level. I'm starting to see a theme here from dyes to displays. It's all about controlling light. Now, this next factoid really caught my eye. Dye-sensitized solar cells, or Gretzel cells as they're also known. Turning vibrant colors into clean energy. How does that even work?
Yeah, so these cells, they mimic photosynthesis in plants. They use special dyes to capture sunlight, and this captured energy then excites electrons in the dye molecules. These excited electrons are then transferred to a semiconductor material generating electricity.
So it's like these dyes are acting as tiny antennas, just capturing sunlight and turning it into something useful. That's incredible.
Yeah.
Seems like we've come a long way from using dyes just to color fabrics.
Absolutely. I mean, we have. And dye-sensitized solar cells, they're still being developed, but they hold enormous potential for renewable energy. Just imagine a world where we can generate electricity from brightly colored rooftops and windows, even clothing.
No, that's the future I can get behind. And speaking of bright futures, our final factoid shines a light on perovskite LEDs. And this is a technology that promises brighter, more energy-efficient lighting with the ability to create, any color imaginable.
Right. And perovskite LEDs, I mean, they're still relatively new, but they're already generating a lot of buzz in the scientific community. And this is because they utilize this special class of materials called perovskites, which have these just excellent light-emitting properties. They're incredibly efficient at converting electricity into light, which means less energy is wasted as heat.
So not only are they super energy efficient, but they can also, change colors on demand. Talk about a mood lighting game changer.
Yeah.
But are they actually practical? I mean, can we expect to see them in our homes anytime soon?
Well, that's the exciting part. While still under development, the research is advancing incredibly rapidly, and scientists are working on improving their stability and their lifespan, and the results so far are very, very promising. Just imagine a world where our homes and our cities are illuminated by these colorful, energy-saving wonders.
From accidental discoveries to futuristic technologies, this journey through visual tech has been quite enlightening. And it's amazing to see how chemistry plays such a vital role in shaping the way we see and interact with the world. But there's so much more to explore, so we'll be back to dive deeper into other fascinating facets of this vibrant field.
You know, it's funny, as we've been talking about these perovskites and their potential to revolutionize lighting, it's a good reminder that technology is just constantly evolving. Even those seemingly magical photochromic lenses we talked about, those have undergone some really significant
Yeah.
advancements.
I remember those early photochromic lenses. They were so slow to react. It always took forever for them to, darken or lighten up.
Exactly. But now, thanks to all these advancements in material science, you have lenses that adapt almost instantaneously to changing light conditions. And, they even come in a wider range of colors and styles now.
So you could be both stylish and protected from the sun's glare, huh? Sign me up. But it makes you wonder what other visual technologies have been quietly evolving, behind the scenes.
Well, one area that's seen some remarkable progress is OLED technology. You've probably heard of OLED screens. They're used in, all those high-end smartphones and TVs because of their, their vibrant colors and incredible contrast.
Oh yeah, OLED screens are gorgeous. The blacks are so deep and the colors just pop. But how do they actually work? Is it something to do with those liquid crystals we were talking about earlier?
Not quite. OLED stands for organic light-emitting diode. So unlike LCDs, which rely on a backlight shining through liquid crystals, each pixel in an OLED display, it emits its own light when an electric current is applied.
So it's like each pixel is its own tiny little light bulb.
Exactly.
That's pretty cool. But why does that make the colors look so much better?
Well, because with OLED, you have much finer control over the light. And since each pixel can be individually turned on or off, you can achieve perfect blacks and just incredible contrast. Plus, OLED displays, they can be incredibly thin and flexible, which opens up all these exciting possibilities for, foldable devices and even transparent displays.
Foldable phones, transparent TVs, that sounds like something out of a sci-fi movie. It seems like the future of displays is getting pretty wild. Are there any other display technologies on the horizon that we should be keeping an eye on?
Absolutely. One really fascinating area of research is electrochromic materials. So these materials, they actually have the ability to change color when an electric voltage is applied. So just imagine a window that tints itself automatically to block out sunlight, or even a car that can change color on demand.
Wow, a color-changing car. Now that would turn heads. It sounds like electrochromic materials have the potential to be used in all sorts of creative ways. But let's step back from displays for a moment. There was another factoid that you shared that I was really curious about. Spintronics?
Yeah.
I have to admit this one sounded a bit like something out of a Marvel movie.
Yeah, spintronics it's definitely a cutting-edge field that explores using the spin of electrons rather than their charge to process and store information. I know it's a little bit complex, but essentially electron spin, you can think of it as this tiny little magnetic moment.
Okay, so instead of just using the on or off state of an electron's charge, in, traditional electronics, we're now talking about using its spin.
Right.
So it sounds like we're tapping into a whole new level of control over these really fundamental particles.
Yeah, that's precisely it. And by controlling the spin of electrons, scientists believe we can create, even faster and more energy-efficient electronic devices. Just imagine computers that are thousands of times faster than what we have today, all while, consuming less power.
That would be a game changer. It seems like spintronics has the potential to just revolutionize computing as we know it. But what about data storage? With all this faster processing and new technology? Or are we going to need like new ways to store all that information?
You're thinking ahead. You're right. Data storage is another area where we're seeing some just incredible innovation. And one technology that I think is particularly fascinating is holographic data storage.
Holographic data storage. That sounds like something straight out of Star Wars.
It does.
How does that even work? Are we talking about storing data in like three-dimensional holograms like Princess Leia?
It's not quite as dramatic as like a holographic projection, but the concept is similar. You see, holographic data storage, it aims to store, these vast amounts of information in these three-dimensional holograms within crystals or polymers. So instead of storing data on a flat surface like a traditional hard drive, we're talking about storing it within the volume of a material.
So we're essentially just packing more information into like a smaller space.
Exactly.
It sounds incredibly efficient, but is it like practical?
Well, that's the challenge. The technology is still in its early stages, but it holds like enormous potential. Just imagine having a whole library's worth of information stored in something that you could just hold in your hand.
A whole library in the palm of my hand.
Yeah.
Now, that's something I would love to see. But, as we like delve deeper into these like futuristic technologies, it makes me wonder, what are the limits of what we can do with like chemistry and material science?
That's a great question, and it's one that scientists are, constantly exploring. And one area that I think like really pushes the boundaries of what's possible is molecular machines.
Molecular machines, are we talking like tiny robots working at the atomic level?
In a way, yes. Molecular machines are molecules that have been designed to perform specific tasks, things like, moving cargo, assembling structures, or even like catalyzing chemical reactions. You can think of them as like these tiny programmable machines that can manipulate matter at the nanoscale.
So we're talking about like engineering at the molecular level.
Exactly.
That's incredible. So like what are some of the potential applications of this technology?
Well, the possibilities are, they're vast. Molecular machines could revolutionize medicine. We could have things like targeted drug delivery, nanoscale surgery, even the creation of like artificial tissues.
Targeted drug delivery.
Mhm.
So instead of flooding the entire body with like medication, we could have these like tiny little machines delivering drugs directly to specific cells. That sounds like something straight out of science fiction.
It does, doesn't it?
Yeah.
But it's closer to reality than you might think. And that's just one example. Molecular machines could also be used in like manufacturing, creating new materials with like unprecedented precision and control. They could even be used in environmental remediation, breaking down pollutants, or, cleaning up toxic waste.
Wow. It sounds like molecular machines have the potential to just like transform nearly every aspect of our lives. But are they like actually feasible? Can we really build machines that are that small and that complex?
Well, the field it's still relatively young, but the progress has been remarkable. Scientists have already created molecular machines that can walk, rotate, and even perform, simple tasks. And the challenge now is to scale up these systems and integrate them into, practical applications.
It's incredible to think that we're like on the verge of a world where we can just manipulate matter at the atomic level. It's almost like having superpowers. But as we continue to explore like the frontiers of science and technology, I think it's important to remember that with great power comes great responsibility. As we delve deeper into like nanotechnology and molecular engineering, we need to carefully consider the ethical implications of these advancements.
Absolutely. It's so crucial that we develop these technologies responsibly, ensuring they're used for the benefit of, all humanity and the planet.
Yeah. It's a reminder that scientific progress should always go hand in hand with, thoughtful consideration of the potential consequences. We don't want to create problems we can't solve. But amidst all this talk of futuristic technology, it's fascinating to see how far we've come from, those humble beginnings with mauveine. Who would have thought that, like a simple dye could spark such a revelation in chemistry and visual technology?
It's a testament to, the power of curiosity and the interconnectedness of scientific discovery. Often, like, these seemingly small breakthroughs can have this, like, ripple effect leading to unexpected innovations in completely different fields.
Yeah, it makes you wonder what other, like, visual wonders are hiding in plain sight, just waiting to be discovered. What, like, seemingly simple concept could spark the next big revolution in how we see and interact with the world.
Well, that's the beauty of science. It's a never-ending journey of exploration and discovery. And as we continue to delve deeper into the mysteries of the universe, Who knows what, dazzling visual marvels await us just around the corner.
Well, do listeners, we hope this deep dive has sparked your curiosity and, left you with this newfound appreciation for the incredible world of visual tech. From ancient remedies to cutting-edge materials, it's clear that chemistry is like the invisible hand shaping the way we see and experience the world.
Absolutely. And as we continue to push the boundaries of science and technology, we can be sure that even more breathtaking visual wonders await us. So keep those eyes peeled and stay curious.
Until next time, happy deep diving.